share some slides. Yeah, Nimrajut, we just covered that. Thanks for letting me know. Yeah, so we're recording the session now. So I've uploaded some of the files. I'm just waiting for them to pop up. Here we go. That should be. Can everyone see that? Yep, everyone can see that the integumentary system slide popped up. Yeah, fantastic. All right, I'm going to shut the chat down just so I don't get distracted. And let's go through. There's about 85 slides here, but there probably was about, I think, 130 or something. But I will skip past a lot more of the others as well. So obviously the learning outcomes is a big thing. Oh, hang on a second. I am going to pause that because I think what's happened is my edited version is not. Okay, give me 1 second. If I save this as a different file, save it as this, maybe the desktop. Give me 1 second, everyone. Because there should be only 60 slides in that file. All right, I think we got it. I will now stop sharing this one. And I'm going to upload more. I'm going to upload a different group of 5 slides. Okay, give me 1 second, guys. Sorry about this. Okay, I'm just going to pause my microphone. Someone's got their microphone on. Okay. Just give me 1 minute, everyone. You know, time always feels like it's, you know, dragging when you're waiting for something impatiently. So, all right. Okay, that's better. All right. So we're good to go? Okay. So what I've done is I've trimmed this back to around 60 slides, as mentioned before, with the error that occurred before with the recording. If there's anyone's got any questions about the second part, 3.2 of the lecture, let me know. That was a pretty straightforward lecture as well. So there's nothing really all that hidden in detail or anything like that. It's pretty much just, you know, the classification and structure of bones. There's a fair bit of rote learning with this sort of stuff, but important parts about the integumentary system, it's basically the skin and accessory structures. The skin, when we say the skin has the cutaneous membrane, it basically means we've got the outer and the inner part. So it's just a membrane, right? So think about your skin, it's a membrane that covers your body. And everything that we refer to as subcutaneous membrane, that actually means below the skin, right? All right. Bit of a trend where one person joins, one person leaves. Geez, it's numbers are steadily going up though, and I hope everyone's been able to get to the study sessions as well. If you have gone to them and you found them helpful, then let me know. Okay, so the integumentary system, as I mentioned, it's the basically split up between I'll put my pointer on, between your skin and your accessory structures. And when we refer to the skin, we're going to refer to the epidermis. The epidermis, as we as we were talking about a while ago, is, as you can see here, it's broken up between the epidermis and the dermis. The dermis actually has blood supply. The epidermis does not. The surface, the very base surface of your skin, does not have. It's avascular, so basically it means it doesn't have, a vascular system there. And what it really does is it's mostly there. It's got little capillaries that it allows gas exchange for as well. So you do a majority of your respiration through your skin. Avascular means lacks a vascular system. So if something's vascular, it means it's got veins, arteries and veins. Avascular, every time you've got a in front of a word, usually it means the opposite. Does that answer your question? I hope it does. Yeah, because the dermis actually has a lot of the blood supply. If you had it wouldn't be that functional, right? Because up here, our whole purpose of our epidermis is mostly for gas exchange and to protect us as well. So if we had too much blood supply being around here, right at the surface of the skin, we would heat up and cool down way too rapidly. Does that make sense? Yeah. I mean, that's all I can see as a consequence of if you did have that. The whole purpose of the epidermis is to really be able to create a fair bit of protection for us as well. Kind of like, the tube on a tire. Okay, keratinocytes are some things that you've got to know about as well. You should know about those. Basically, what it is when we talk about keratin is it's fiber, right? And what ends up happening when you have thick skin, the very top of it is just full of these cells which are jam packed with keratin, and that's what makes them really tough. Now, thin skin covers most of your body. There's 4 layers of keratinocytes. Thick skin basically has an extra layer, and that's why it's typically much thicker. This is what you do need to know these layers. If you know these layers, you're going to be okay. You only really need to know them in this depth as well. I'm not going to quiz you on anything beyond this particular slide in the exam at the end of the semester. So know those particular layers. The coolest thing about skin is it all starts off as stem cells. So the basal level or the basale level, depending on how you want to pronounce it, is basically stem cells. And what they do is they differentiate as they go through this migratory patch all the way to the top. By the time they get to the top, they're packed full of keratin. Okay, you've got to know the basic structure of this. You've got to know the basic structure of the dermis, right? So again, this is below the epidermis, and but basically what what you should be comfortable with being able to identify is the outer papillary layer, the deep reticular layer, and you should right now be able to look at this and go, okay, that's likely going to be a gland over there. There's red and blue things here, so that means we've got an part of the arterial system, part of the venous system, which later on in the semester you'll be able to identify that. Don't worry, there's a lot of these other things as we talk about them throughout the semester that you'll be able to recognize. I just thought I'd leave this one here as a little bit of an odd fact. The chances of you being quizzed about tension lines in depth is going to be very, very minimal. It might be a multiple choice question or something like that. But it's really easy one to remember and quite interesting. Did anyone actually ever think about this as to why some little cuts on your hand or something are scarred more so than others? Anyone? Yeah, I mean this is it. It comes down to tension lines. So other thing I always find interesting about, just wonder why certain scars not fade away months. Yeah, so basically if you cut yourself along this tension line here, say if you get a little cut on your hand and it goes along the tension line, it's very, very easy for it to stitch back together because there's no resistance. It actually wants to be on that, the way that the actual the fibers are, they want to actually be there. That where White-Langer's lines come in. I've never heard about that White-Langer's lines. What That's interesting, though. I might look that up soon. Um, but if you end up cutting yourself and you go against the grain of these particular lines, um, oh, okay, you know it on the neck. That's mostly in regards to the folds of your skin. Um, and it might, yeah, and it might vary. Usually, that's around areas where you've got thinner skin as well. So tension lines would contribute to it. Definitely, they do. But the thinner the skin, the more they're going to end up wrinkling and creasing and losing elasticity. More just cuts in regards to that. Because what ends up happening is once you cut these things, imagine if you cut at a 90-degree angle to this tension line on the thigh here. That means that while it's trying to fill up and stitch together with the scar tissue, it's also being pulled apart from the tension as well. So there's going to be a greater wound there than there will be with something that's going along the same tension line. Yeah, really good question. It comes down to being able to look in a developmental context how those fibers sort of all stitch together, and then as you go through life, just going through and having a look at the way skin sort of works, is you can actually see that there's a particular ways in which the fibers tend to stitch together and move. Usually, it comes down to muscle groups as well. That plays a role. Muscle groups and skeletal sort of structure too, because obviously that's going to be more in line with. It's not going to go against the fibers are not going to stitch together in a way where it's going to have a lot more resistance from the anatomical movements. I hope that makes sense with what I just said. It's making sense while I'm doing the motion in my arms. The tension lines relate to the fingerprints. That's a tiny little bit of a different thing. So they do, but they're deeper in that regard. There. Did I delete it out? Here we go. Uh, your fingerprint is due to the epidermal ridges that you have on your skin. So that still is fiber lines. It's kind of like mini tension lines almost. Really good question there. But yeah, your own individual epidermal ridges are exactly why you end up having unique fingerprints. And they're kind of like tension lines, but that's all on the epidermis, whereas tension lines themselves here are due to all these collagen and elastic fibers that you have, and they're in the dermis. So does that make sense? Fingerprints are on your epidermis, whereas this is on your dermis. Good stuff. You should know skin color, right? It comes from melanin, that's your red-brown pigment. You should also know carotene, that's the orange-yellow pigment. And basically that's those things coupled with blood supply is what's going to make your skin a particular color. Pretty cool stuff, huh? And the myth of eating carrots in World War II, they used to feed soldiers carrots, so they thought they'd enhance their eyesight. That's because you get carotene out of carrots, and that's good for the function of your eyes. It doesn't enhance your vision though. You're not going to have supersonic vision. Oh wait, sonic surround sound. You're not going to have super visual vision, right? If you're going to be snacking on carrots all day, just means that you'll be able to maintain um, uh, normal health of your retinas and stuff like that. Okay. Pink carotene. Uh, Hang on, we'll go back here. So carotene is the orange-yellow pigment. Gets converted to vitamin A, whereas your melanin is the yellow, brown, black pigment. Your accessory structures, now in terms of this, only oranges ones have. Yeah, so vegetables that typically have that orange sort of pigment in it as well is largely due to carotene. Okay, so accessory structures, you don't need to know as much about this is what is on here. I've removed some of the one. I'm not for some of the questions here. Now, you do need to know about your sweat glands. You need to know the difference between your different forms of sweat glands, your apocrine sweat glands and your eccrine sweat glands. You need to know those, or eccrine sweat glands. The apocrine sweat glands are the smelly ones, right? And that's because they produce a nutrient dense level of sweat. They're usually in your armpits, around your nipples, your pubic region, all that sort of stuff as well. That's why in summertime you can sweat a lot from in terms of like the surface of your arms and your legs and your chest, all that sort of stuff, and it's not too bad. But it doesn't smell, it doesn't stink. But under your arms, that sort of stuff, it's going to be pretty stinky. And that's because it's an apocrine sweat gland or apocrine. So, whereas the ones that you actually have on the surface of your skin, they're basically just water and a little bit of salt. Their whole purpose is to cool you down, not make you stink. So they're less of a meal for bacteria. Remember, we are dirty animals, really. We are covered in bacteria and fungi, right? We have a lot of bacteria and fungi on us. It's all kept in balance. It's all kept in check. But sometimes this is where disorders like fungal disorders and stuff like that can occur and get out of hand. And that's when you might end up having things like athlete's foot and jock itch and those sorts of things typically come because you are feeding the actual fungi more so than what it needs to have. And that's because you've created a sweaty, moist environment in your feet. And that's one thing that fungi particularly love. the other things, sebaceous, the other glands that we actually have that you only need to know the basics of is your earwax, the glands that produce your earwax, your ceremonous glands, and your mammary glands, which produce milk. Other than that, you don't need to know a great deal about that stuff. Nails, you only need to know the basics. I'm not going to show you a overall structure of hair or nails or anything like that in the exam and say identify every section of that. There's a lot going on in that hair image as well. You definitely do not need to know everything about it. You should be able to identify a hair root if I actually showed you a cross section of skin. On some of these images we've got, you should be able to, by the end of the semester, identify the main components. But knowing the very, very nitty-gritty parts about hair is going to be we're not expecting that to occur. You've got to know how the skin repairs itself. Basically, what you end up having is basically you got to clean the area out with your immunity comes into play here. Clears the area out. That's basically done by all your macrophages, and then your fibroblasts and endothelial cells will basically produce what will be the precursor to scar tissue. So remember, so the inflammatory process occurs initially, and what the inflammatory process does is it creates. Everyone thinks the inflammation is a bad thing. It actually is to a certain extent, but one of the reasons why it exists and why it works is because it creates more of a surface area for all of your your molecular machinery that's going to repair something to come in. That's why when you get a little cut, it flares up with the immune response. That's so that you got a greater surface area for all the good stuff in your body to come in and fix the problem. Pretty cool, huh? Okay. Yeah, I'm glad you think that, Harland, as well. I think I like it.
What the fuck is that? It's funny, microphones.
Here we go. All right. That sounded like a dolphin or a whale or something like that, deep down the sea. It's like, it was good. It was actually, kind of dancing to it a little bit there as well. I mean, it definitely had me moving. Okay, the aging and your skin. What ends up happening is it thins. Remember, the thinner something is, the more it's going to crinkle up. And a whole bunch of other things start to go all haywire as well as you get old. The dendritic number of dendritic cells decreases. So that causes a bit of a problem. You start to lose that integrity of it. Vitamin D3 declines. A whole bunch of things start to decline as well. And really, it's just all downhill from here as you get older. This is a really good study just to give you the whole overall gist of things about your skin. And now that we've done the skin, we're going to move on. Now, the important parts of the skeletal system, part 1, this was the actual lecture which had the recording problem as well. So if you've got any questions in regards to any of the slides on this one, then let me know. But the main things that you got to remember about this, there's only 4 learning outcomes, so it's pretty straightforward. You've got to know the major functions of the skeletal system. That's a bit of a no-brainer. You've got to be able to explain how bones are categorized by their shape and how long bones are categorized by their structure. And that's basically, there's 3 different bits of nomenclature you've got to know about that. You do need to know the difference between compact bone and spongy bone. That's a given. And you've got to be able to identify the 4 types of cells that are associated with bones. Now, there's only 2 classes, right, in terms of bone development. There's 2 classes because one is the precursor for another 2 of them, which are essentially involved in bone growth. And then we've got another class which does the opposite. That secretes acid, and that helps shape and mold bones into correct, into its correct function and stuff. Okay. So a couple of things about your skeletal system. You've got to know about the bones, the cartilages, ligaments, and other connective tissues are connected, associated with it as well. Do not, there's a question in the quiz. I might be giving this away a bit too much. There's one about that includes, is tendons part of this? And no, it's not, because your tendons do not connect to your bones, right? This is all about stuff that's going to connect to your bones. Now, we classify bones by their shape and their structure. You do need to know these classifications of bones. You need to know, don't get confused about the difference between sutural bones and flat bones. Sutural bones are ones where we refer to at having these suture lines. So sutras is another name for stitches, and this is because when your skull's developing, it's separate components, and then they all kind of merge together as growth occurs. You should know the difference between a sutural bone and a flat bone, because they can be. That's a bit of a booby question that a lot of people get wrong. You should know what an irregular bone is. It just doesn't fall into any of these categories. A short bone don't confuse that between a flat bone. These carpal bones are kind of like little rocks. If you think about the way that they're put together in your hand. Long bones are self-explanatory. You've got to know the main components of those, and we'll talk about that in a minute. And your sesamoid bones are things like your patella. You should be able to differentiate between that and anything else, in particular your short bones, because your knee bone is not short. So don't confuse that, because it's got a similar shape to some of these carpal bones that would be classified as short bones. You do need to know this. You should be able to look at this and go, oh, cool. Like if I showed you a big femur, and I was like, check out this femur. This is from someone who was 7.5 foot tall. And you should be able to look at it and go, wow, that's some diaphysis, like you should be able to start wowing out about that as well. Remember the top, just remember the ends of the bone is your epiphyse. The diaphysis is the shaft. That's the main part that you would be wowing out over. And then the metaphysis is the junction where the epiphysis attaches to the diaphysis. Good stuff, huh? In the epiphysis, it's mostly spongy bone, and that's because it really is a house for a lot of marrow as well. Remember, your femurs are big blood cell generating factories, and there's a lot more going on in bones than you'd think, right? You got to know the types of bone cells. First of all, your osteogenic cells. They're ones that are essentially your stem cells, which are going to end up being able to produce osteoblasts. Your osteoblasts are basically these immature bone cells. They go out and try and start to form the matrix. And then your osteocytes are ones that maintain the actual matrix of the bone as well. Now, all three of those are related. They all originally differentiate from osteogenic cells. Osteogenic cells differentiate into osteoblasts, and then they differentiate and mature into osteocytes. Whereas your osteoclasts are a different class, and what they do is they shape and remodel things because they destroy bone. This is a good way to think of it. It's 4 different types of cells, but there's really only 2 because osteoprogenitor cells will differentiate into osteoblasts, then osteocytes, whereas your osteoclasts are the ones that are going to dissolve parts of the bone as well. So think about it when you're making bones, when your body's making bones, it just builds up layer and layer and layer, and your osteoclasts come in and they start to subtly remold everything, just to reshape everything as well. Okay, you should be able to know. You should know the difference between compact bone and spongy bone. In terms of here, the main component of bone is called a unit of this is called an osteon. It's basically 1 unit of mature bone. You don't need to know everything that's on here. Okay, there's a lot going on this slide as well. But you do need to know the basic components of spongy bone and compact bone as well. You need to know these terms as well. You're going to need to know the overall network of spongy bone. In terms of, you should be able to look at an image like this, and you should be able to identify all of these particular structures. They are terrible tongue twisters as well. Most of them come from Latin and Greek terminology as well. So throughout this particular unit, if anyone has any knowledge of Latin or has a Greek background and you end up getting triggered by my mispronunciation of Greek words, then my apologies right now, and I'm apologizing in advance. Okay, the periosteum, you've got to know that's the membrane that covers the outside of bones. I always think of it as kind of like the epidermis of the bone. It's called the periosteum. This is where you end up having a whole bunch of other things that will kind of connect on, especially those associated with tendons and other fibers and all that, cartilage and all this sort of stuff as well. So it's kind of creates a nice barrier as well. And it's also got an actual, it provides a route for your blood vessels and nerves as well. Okay. The differences between compact bone and spongy bone, as we're talking about, you should be able to identify a lot of these things here. Try to just know the actual basics, okay? You're not going to need to know it as in-depth as what you would have in the textbook, okay? And don't worry, I'll put up some past exams shortly as well. I think after week 5, I'm talking to the library to try and get them put into the actual database of past exams, but that's proving to be a little bit difficult at the moment. I might have missed the cutoff as well. But like I said, they haven't normally done that throughout this unit, which I think is a bit unfair to you guys as well. You should be able to at least see the trend of how we ask questions. Bone development's broken up into ossification, and that's when we talk about bone formation, and that can be further broken up into calcification, which is the deposition of calcium salts. That's an important part of ossification, but that's only one part of it. Now remember, there's continuous remodeling going on as well. You end up having those 3 particular cell types, which are just different maturing stages of osteoprogenitor cells, but then remodeling is going to involve the osteoclasts. Remember, osteoclasts are going to like trim things back, and your osteoblasts are going to build them. And there's always a really cool balance going on between building things up, because remember, every time if you go to the gym, I almost said if you go to the weights, if you go to the gym and you pump iron, anyone here pump iron? Meaning go to the gym and you lift weights. Yep. So Jack does. So Jack said, I said, yeah, yep. Artland, yep. You pump iron, yep. Yeah, fantastic. Yeah. Yep, Ryan's giving it heaps as well. Okay, so every time you're in the gym and you're giving it heaps, by the way, I call a gym a gym. I've always called it a gym. So when you're in the gym and you're giving it heaps, what you're doing is you're actually causing stress on your bones, and this is why it's actually really good for your own health. So in fact, we'll go straight to this now. One of the coolest things about this is that when you're pumping iron, you are essentially Jim Bros, you're essentially stressing out your bones. You're actually causing little micro parts of damage. It's almost like very similar to when we're actually when you the effect on muscle, right? When you build muscle, you damage the muscle, and then it comes in and it heals up. You can lose that muscle mass much quicker than you can bone mass, although bone mass does deteriorate quite quickly as you get older. But what's so important, and this is one of the reasons why, like even just doing moderate exercise as you're older, that put your bones under a bit of stress is actually good, and that's because it participates largely in mineral recycling. The bones are going to become thicker and stronger, and that's really important when you become old and frail, and you're going to fall over and potentially, break bones much easier as well. So yeah, keep pumping iron. And feel free to refer to a gym as a gym as well. I say that and my kids cringe every time I say it. Oddly now, though, if I say to my kids I'm going to the gym, they say, "Oh, what do you mean?" I say, "Oh, the gym." And they go, "Oh, the gym." Okay. In terms of the divisions of the skeleton, you've got to know the difference between your axial skeleton and your appendicular skeleton. Really easy stuff to remember, okay? Print this off, put it up on your wall, and you should, it should be quite easy for you to remember. You do not need to remember the names of every one of these bones. Actually, it would. No, you should be able to know this, and you should know a majority of this anyway. The only ones that are going to be probably a little bit hard for you to remember, maybe the sacrum, maybe the hyoid bone you haven't heard a lot about as well. But everything else, your cranium, your sternum, ribs, all those things, not very hard stuff. So yeah, you need to know those. This is our axial skeleton. Think about the axial skeleton it's the protective skeletal structure, right? So our brain's going to go in our skull. Our major organs are going to be protected by our rib cage, and our spine protects essentially protects our nervous system, right? Our spinal cord. Okay, the axial skeleton, it has 80 bones. You just need to know the basics of this stuff as well. I might end up quizzing you a little bit on the vertebral column in regards to what makes up all the different curves and stuff like that as well. I'm certainly not going to ask you about how many bones associated with the skull, and how many facial bones we have. I'm not going to ask you that in a big question. Now, keep in mind, I can't tell you guys 100% of what's going to be on the exam and what's not going to be on the exam. Those of you who study in depth are going to, are probably going to do better than people who don't. But I'll try and give you guys enough information so that you don't go focusing on the wrong things, right? So you don't get stuck on a couple of slides and then there's no questions on that at all. But keep in mind, there might be, because in the exam format, we're going to have, there's 60 marks which are multiple choice and then 40 marks which are long answer questions. The long answer questions, don't worry, I'll let you know what you've roughly got to know, right? But in terms of these smaller questions, pass mark for the exam, Sarah, is there's no pass mark really. It's 50%, obviously, if you pass, but you need to just get an overall 50% for the entire unit. But I guess what I'm saying is that with those smaller questions, and even with the quiz questions as well, I've had a few people say, "Hey, there were some quiz questions that weren't in the learning objectives," and I'm like, "You can be quizzed on anything. Technically speaking, you can be quizzed on anything that's going to be in the learning material as well. So there might be a question, multiple choice question, that might end up, asking you a little bit about the skull cap or something like that. But you're not going to be expected to have large questions that are going to be based on it as well. Are these slides on the modules? Yeah, these slides are on the modules. Every week 1, week 2, week 3 is, or there's different modules for that as well. Okay, so everything as mentioned in the announcements is located in the modules. Where were some of those other questions? Sarah asks, if you get under 50 on the exam, will you fail the whole unit or no? No, it's mentioned on the unit outline as well, Sarah. You just need to. So when you're at uni, some if it mentions that there's no hurdle requirement, it would then that means that you just have to get an overall cumulative 50% to pass. Most of your subjects will be like that. Some of them more uncommonly might actually have the demand that you need to achieve a certain score in the exam to pass. Okay, I'm going back to my slides. Okay. All right, so you need to know these curves. You need to know the curves of your spine, and you need to remember, very, very easy to remember, okay? Just the way I remembered it is C7, T12, L5. That's the 3 curves done. So obviously, so there's 7 cervical vertebrae, 12 thoracic, and 5 lumbar. It's also really helpful as well when you're, when you're trying to tell, like a masseuse or something like that, a physiotherapist or something like that, where you've got pain as well. If you say you've got a bit of upper back pain that's around your T3, then immediately they're going to go, wow, I know exactly where the pain is now. Okay. You need to know the vertebral anatomy as well. All you need to be able to identify is the vertebral body, the vertebral arch, and the articular processes. These things here, you need to be able to identify. If there was an image of this, you should be able to, I'm not saying you need to label it with everything that's located on here, but you should be able to identify what the intervertebral discs are, the foramina. You should be able to understand what those are, and you should be able to identify the vertebral canal. That's basically where your spinal cord is going to travel through. The thoracic cage, you should know the difference between your true ribs and your false ribs. You should be able to identify the sternum and the xiphoid process, which is just the tip of your sternum. Hurts when you get hit there as well. Could you show where the 3 parts of the vertebral column in the second diagram? 3 parts of the vertebral column in the second. So here? Is that the one here? The next slide. Oh, yeah, this part here. Yeah. Yeah, so this one here, this is a good one to be able to recognize. Just remember, this is a bird's eye view here. You've got your vertebral body here. This is if we're looking down from the top. This is your vertebral arch. Again, very, very identifiable. And then the articular processes are the things that are coming off the side here as well. And again, if you look at on the side here, it looks a little bit different too. Okay. You should be able to differentiate between the true ribs and the false ribs. Why are they called false ribs? That's because they don't connect to the sternum itself. So just go back here as well. Your false ribs just basically come off. They're just an extension of your 7th rib as well. So your true ribs are ones that are going to connect to the sternum. So yeah, you can count them here. All the ones down here are true ribs, right? Whereas everything else down here is coming off your false ribs, and then your floating ribs are these ones at the back that, as you can see here, that don't actually connect to anything. Okay. Your appendicular skeleton is associated with your movement, really. And you've got to know the actual, the supporting girdles as well. We've got a shoulder girdle and we've got a pelvic girdle. You should be able to identify that if I asked you in an examinable format to explain the pectoral girdle, including all its major bones, you should be able to say there's a jugular notch, clavicle, and the scapula. these connect to this. These basically connect to the actual skeleton, and the whole idea is that it's what allows that particular movement. And we're going to cover this in next week when we go through joints as well. You should be able to identify the main bones of the appendicular skeleton. Again, there's not a lot of them, so it's actually quite easy, right? So upper bones, you've got your humerus. Humerus is actually, I'm pretty sure that's where the idea of the name funny bone came from. Nothing funny about pinching yourself around the humerus. Your forearm is got your ulna and your radius. Those of you who have broken your arm before, mostly likely the chances are you've broken your ulnar bone. It breaks a lot easier than the radial bone. It's also the one that's located at the base of your arm, which is where you're going to connect a lot as well. So you should be able to know those. I am not going to quiz you on the actual individual bones that make up your wrists and your hand, right? So you should know the basics. You should know what your metacarpals are, but I'm not going to ask you. I'm not going to say to you, name the distal carpal bones in the upper part of the wrist. So, or the proximal carpal bones. So you don't have to remember those. Okay. Hope you're relieved for that, because I had to remember those when I was studying and it was terrible. Okay, so the pelvic girdle also has two hip bones. One's called a coxal bone or pelvic bone, and they attach to the lower limbs, right? So each hip bone has three bones that are fused together: the ilium, the ischium, and the pubis. Now, this is quite an odd one, right? Is there a difference between your sex and your bones? Yes, there is. There's a reason why when they find a skeleton, buried out in the middle of nowhere or something, and they can identify it as being male or female. That's because our skull, the male skull, is different from the female skull. The male pelvis is different from the female pelvis. There's actually differences in other bones as well, but the skull and the pelvis are the two main ones. And I guarantee you, I kid you not, if you give me a pelvis, I'll be able to tell you if it's male or female. And that's most of the way is that the female pelvis is going to be shorter, wider, and it's got a greater area of opening. So everyone misconstrues this idea of genitalia being one of the reasons why women, especially when they're younger, can do the splits a lot easier than men when they're younger. It's not due to that at all. It's actually due to 10 degrees more of angle that females actually have compared to males. Here, this is me with my lack of flexibility, and this is, obviously not me with greater flexibility as well. So there is a difference there as well. The skull, though, actually, it is quite interesting. In your textbook, there's a description in regards to male or female bone types, and there's, a big difference in regards to those. So that's quite interesting. The lower limbs, once we get down to there, only a couple of slides left, everyone. So you should be able to remember the femur, the patella, tibia and fibia. It's in the leg, in the lower part of the leg. Your tarsal bones, your metatarsals, and your phalanges. Your tarsals, your metatarsals, and your phalanges are not going to be quizzed too much, but you should be able to, if I was to show you an image of, of one of these skeletons and say, hey, what's, point the major bones of the leg out, you should be able to tell me which ones are what. Your femur, obviously, is a really cool bone, produces a vast majority of your red blood cells and your immune cells as well. Really cool stuff. We'll talk about that later on this semester. And this is it, lower leg. You've got your tib and your fib, your tibia and your fibula. So pretty cool stuff. All right, that's all we got time for. We're going to open the channel to some questions if anyone has any. How do you remember all of this? It's a really good question there, Khan. Learning by rote is necessary in this unit, unfortunately. You're learning a language really when you're learning this sort of stuff. But don't worry, the more and more exposure you get, there is a lot of information. But I don't want to sound like one of those people who says back in my day, but I'm going to do that now. Hair shaft and follicle are they the same? One's an extension of the other. Your follicle essentially is, the follicular part, whereas the shaft is the one that embeds into it. When we submit our work, does it have to be? It has to be in PDF. Yeah. Follow the instructions because the instructions say you've got to do PDF. The reason why that is because when you have when we grade things through Canvas, if you've uploaded a Word document, it won't be able to open up. So it just shows it as code. So it doesn't actually show it as a PDF. So I think PDF keeps the integrity of it. So yeah, unfortunately, there is a lot of learning from rote, but with this unit, and then you've got to end up that's the lab books, yeah. And then once you learn everything by rote, then you actually have to be able to, apply your logic to it as well. How nails are similar to thick skin? Because they're full of keratin. Good question there as well. Actually, this is a bit of an odd one, but rhinoceros horn. There's a black market where people go and kill rhinos because they think in some traditional medicines that rhinoceros horn is either an aphrodisiac or it'll be a cure all for cancer and stuff like that. That's mostly just keratin. So if you're snorting rhino horn or eating rhino horn and making a soup out of it, you may as well be doing that with all of your fingernails. Yeah, keratin's super common. So constant remodeling of the bones. Why we have to wear? Hang on, I'm gonna some of these questions here. Is the constant remodeling of the bones why we have to wear casts after breaking them because they will just keep remodeling the wrong way? Yeah, that's a very good question there, Mo. And what will happen, Mo, is you'll end up, it has to keep it fixed as well so that it will heal correctly because your bones will continue to heal with, and if you've got movement there, they're just going to if it's curved, for example, it's just going to repair in that way as well. Now, Frederick, I mentioned that. You don't need to know the thyroid bone. Okay. And don't worry about the exam structure. We're going to do a revision session on that anyway. Should you keep taking notes, since you can just go back to the slides if you like. Best way to study for this when it comes up to the exam is with each lecture, each week, just write out the learning objectives and just be able to look at them, and you should be able to sort of say them out loud. The answers to them. It's probably one of the easiest ways. All right, I'm going to get back in. I'm going to end this now because we're going again in 9 minutes. So I'm going to go get a coffee. We've not done the types of vitamins, cells, so we just need to learn. Should we do reading on this? No, you don't have to cover the vitamins or anything like that. That's going to be in this. Really, in terms of what you mean skin color. You should know melanin and carotene in regards to that. You should know that your skin's involved in D3 or anything like that. But yeah, all I can say, Nerajot, is that you've got to focus on the learning objectives. That's what the main parts of the lectures are. But then anything else in particular about that is good to know as well. It depends how far you want to take this. So Khan, in all of your units, every bit of teaching material is accessible. I'm just trying to be a bit more kind and give you guys a bit more focus in regards to what we're mostly going to focus on because there's a lot of content here as well. Module quiz, the ones that contribute 3% of the quizzes are different. Yeah, they're for your own learning. The only accessible stuff is the quizzes that we do that are worth 3% each, your labs and the exam. All right, everyone. Thanks very much for today. If you've got any questions, let me know. And live session for week 2, carry on. If you go onto that date, you should be able to click on it. Let me know if you got a problem with that. Okay. All right, everyone. You're welcome. Have a fantastic day, and I'll see you all later.